Hello, guys. Glad to see you today here. Today we will be talking about Java Streams. It's a feature that first appeared in Java 8 and then it actually developed a lot throughout to Java 17, I think. And the speaker here today is Alibek. He will show you the examples of using streams, and we will go through the main methods of streams so you can interact with your data, transform, analyze it much easier than with simple for loops and other simple Java stuff. Uh, Remind you, as always, we have chats and you can ask all your questions there. We will try to answer all of them. So I'm passing word to Alibek. Good luck.
Okay, thank you. Hello, everyone. Welcome to our stream today. So, stream about streams. Sounds funny. So, let me tell about what streams is. So, they were created, not how I wanted to start before. So, it's not one of the obligatory topic, because you can write pretty much everything, all your code without streams. All streams do make your code more beautiful and make your code faster and much less than in the classic way. And it mostly work with some collections, sets, arrays, maps, hash maps, anything of that. So before we dive in, I wanted to just go a little bit in advance and show you one example. So, for example, we have some array of integers. Let's imagine it's like price. And what we want to do, for example, a customer want to see all goods which is less than 300, for example, price. And for some reason we collect it like with extra zeros, like pennies, and we need to remove them, like remove zero from the end. Then he want to sort it from the minimum to maximum, like sorting, and then wanna see like top three, like three the cheapest. So how would we do that with the classic way? I guess we would do some loops. When inside of these loops we had some condition. If it's less than 300, we would remove this. And also we can remove 1 0, just dividing by 0. To sort, we would need to create another loop, actually two loops inside each other, and use some bubble algorithm to sort things out. And then top 3, we can just print from 0 to 3 or just remove unnecessary data. You know how it's done by simple way. And now let me show you how you could do this using streams. So I can create arrays stream, and I can create stream from this object. So now stream, and we can use any operation of streams. First one, we need some filter, and show x, it's lambda expression, and we want x less than 300. And next operation, it would be map, and we want to remove 1 0 at the end. So how we do it? We just divide by 10. Then we need to sort. Instead of double loops, all we need to write just one word called sorted. Yes. And then we want to show only top 3. So there's another operator called want to show 3. And that's pretty much it. Now we can use operator to try to take in our console so we could see what inside. So let's start our code. Yep, you can see we removed all more than 300. It's 400, 300, and 104. Then we removed 10 from 200, 1200. It's just 12. No, it actually is this one. Because after that we sorted and took only 3, the minimum. So it's 100. This one, and then this one. So that's actually what streams for. Instead of writing tons of code, you can use just one line. Actually, it's not very beautiful, so usually streams written this way. Good idea. So now let's dive in and go one by one and figure out how to work with these commands. First, let me show how we can create streams, because streams, it's kind of a different object. So we can create empty stream. If we have a list of objects, we can use this construction. If map, we have to create enter set them streams or arrays, which we just used, or the simple way for examples and testing, just create stream of some value like this one, and we also can print it. I should remove that. So we don't need this one. So let's create stream of some value and print it out. Next, let's see how we can generate different type of streams. One you already see, it's stream of. The second one we can actually most of the time we just not generate with constants. We use some object, and sometimes the object could be null. So to avoid some error, we also could use another construction called null of. Sorry, streams of nullable. It's pretty much the same as this one, but if we, for example, have some object and it's null, instead of returning null and then causing some null pointer exception, it's going to return empty stream, this one. Or if you already know that you have object that it's null, there's nothing else, you can just generate empty stream and return it. So it's just mostly for avoid exceptions, like null pointer exception. Now let's see how can we generate some stream. If we need to create some data, we can use operator generate and write its empty function and any object, a number or any thing like hi, and then we can print it out. What's happened here? We let it wait when it starts. So we generated just this object hi, and it's never going to stop until we get exception out of memory or some timeout, because it's just endless loop. So to avoid this one, we already know some command called limit. So for example, I want just 5 highs. I can start. Now you see I have only 5 object. So generate the same object is not very useful. So we have some OSI command called stream rate. Yep, this one. So here we can indicate where we want to start. For example, it's going to be 2, and we use lambda expression that x, and it's, for example, +1, or let's use +2, and the same print out. So now we're going to increase, but telling in advance. It also endless loop, it's going to increase endlessly. So we also have to apply some limit here, for example, 6. So let's see. Yeah, here you can see it started 2, then we added +2, 4, 6, and so on, and overall 6 objects. Also in Java 9, they added another operator. It's pretty much the same, but inside you can add conditions like x and x, let's say 20, and we use 4 here. And we don't need to use limit because it's going to generate amount of x until this condition is met. Let's check it out. Yep, we created from 2 to 18. 20 not included because it's less than 20. So it's more interesting approach to generate string. Now, what else? For example, if we have a couple of streams, we can concatenate them pretty much the same as any string. For example, we have a stream of and we have another stream. 3, 4, 5. So to create new streams which combine both of them, we can create operation called the same as in string, just concat, which stands for concatenation. And since it's to the streams, comma, and yep, we don't need this one. And we can do any operations, any stream operation after that, or just print it out like this one. So it's gonna be from 1, 2, 3, 3, 4, 5. I guess. Nope. I forgot semicolon. Yep, I have 1, 2, 3, 3, 4, 5, and it's one stream, and we can work on all this data. And sometimes we don't have data in advance. We get objects one by one, and streams mostly immutable. And to create mutable, we can use some construction. Let me copy paste because it's a little bit big. This one, it's a stream builder. We indicate that it's a type of integer, and we create stream, and we can just add one object, another object, and after some, so we can just add another one, like 3 and 4, and then Then to create stream, we need just cs command build, and that's it. We have our classic stream with all data, and we can just print it out. So nothing. This one I don't anymore. Let's see. Yeah, it's 1, 2, 3, 4, and build. That's how we can create classic streams, and with any object also we have some streams which contains only numbers like integers. Comments this one, like int streams. It's pretty much the same streams, but all objects must be integers. And it has other functions which can work with only numbers. For example, we can generate a range of numbers, like from 1 to 10. So in this case, we don't need to write like this when we indicate how much we need to increase. When we stop, we just say create for us a range from 0 to 10, and then print it out. So now we see we have from then 0 to 9, because the last one not included. But if you need to include this, there is another range called range close. Yeah, this one. This one is pretty much the same. It's just include the last one, 10. Right, let's check it out. Yep, you can see it's 10. Or you can use it, solve this issue, just like adding 1 here. Or the separator, that doesn't matter, up to you. So that's pretty much it about generation of streams.
Yeah, I forgot to unmute myself. We have one question in the chat that is related to int streams, so I think we can ask it now. The question is, are there any performance benefits of integer streams, int streams, compared to the usual streams?
Well, we always can check it out in performance testing, but integers usually much more faster, because it's based on primitive numbers, and it's work much just Java working with numbers faster than with any objects.
Yeah, I would say that int stream doesn't need boxing internally, so it can work with int, not object integers, so it shall be faster. But actually, the question was, is it not more performant to map to int before processing ints? It was about your first example with integer array. I think it would be more performant, but the idea was to show the main methods, not to give hints on some performance optimizations. But yeah, I think you're correct. It would be more performant.
Yeah, in general, as I said, streams is not for performance or making something faster or better. It's more for you to make your code looks more beautiful, more short.
Yeah.
Because sometimes actually streams could be much worse at performance than basic functions.
Yeah. Okay. I don't see any more questions for now, so I think we can go further.
Yeah. Okay. Thanks. That's so. What we stopped. Yep. Creating. Now we're gonna dive into some. No. Let's call it. Oh, by the way, let me explain. At any interview, when you will be asked about streams, first question will be, what two types of commands do you know about streams? And the answer is terminal and non-terminal. And then the second question is usually what's the difference between terminal and not terminal. So the difference is terminal, it's kind of say for itself. It's terminate the process of stream, and it's only one in stream. It's usually stands at the end of the stream, like for example this for each. And non-terminal, it's all command in the middle which do some operation with data but allow you to do something else. It's like as our first example where it was, oh sorry, I deleted it. So anyway, you can create as many as you want non-terminal operation and then finish it by terminal operation. And another interesting thing, oh no, I explained it later with another operation. So non-terminal. Non-terminal. So first one you already know, it's for each, which go through all the stream data and apply any function you write here. Next, let's use a filter like stream of filter. So filter, we already used this command. What it does, you just say pass any conditions like in if statement. Oops. Says X, and what you want to do with it. For example, I want to show everything which is what is that? More than 100. Out. So it's removing all the data which is not applied to these conditions and return only data which apply to that. So just stream, not in streams. It could be any object. So it could be, for example, your customers or some price, and object it could be like, for example, you have customers and pick only males, and you say gender equal something like that, or you wanna check how many age you have, age more than 600 or anything. But to make it faster, we're going to use just integer like this one for our examples. Another one is map. We also used. Actually, let's just paste it. Or no, let's use strings. So map. Why did I remove this? It's apply any functions inside of it to each element. We used, as you remember, we removed 1, 0 by just dividing it by 10. But here, for example, we have strings. Oh, yep, strings. As usually, it comes from front end. And in map, we also can use functions like parsing. So let's say we want an integer, and it says parse int. So after that, here we already have streams of integers, not strings. And we can apply any math functions to that.
Yeah, but I think it should be a method reference, not just a method call.
Yep, sorry, thanks. That's parsing. Yep, this way. And for example, we wanna add like 10. And we just printing out. This one and see. Yep, first we created numbers 3, 4, 5, or not, what is it? Plus 10. Ah, yep, that's right. I thought I multiplied to 10. Now we have 13, 14, 15. And as I mentioned, you can add any filters and remove and do any separation you want. So let's go further. Also, there is some map called flat map. So let's create string. 1, 2, 3, oops, 3, 0, 1. We can create something more complete. It's pretty much the same as flat map, but it can take any more difficult expression and then turn it into string. For example, we show like side we have int string, for example, and we can create page from 1 to x. And just print out. Oh,
I think it doesn't compile because you flat map to int stream, and maybe instead of it, the method should be flat map to int.
Yep.
Yeah, so if your nested function returns just a stream of elements, then you can use flat map. But if you return int stream, that is not actually a class inherited from the usual stream, you have to use special methods, but it's just for cases when you're playing around with it or when you're trying to make it as performant as possible. Yeah.
Yeah, thanks. So how it works, so it's kind of inner loop. We created a range like we did before from 0 to, but here we use for x, and x it's this number. So first we're going to create from 0 to 2, then from 0 to 3. So just let's see the result. Yep, so from 0 to 1, so it's map just creating another integer stream and then combine all of them together. And also it's figuring out, for example, here from 0 to 0, we would have null pointer exceptions, and flat map just return empty stream, comparing this with just map, which would return a reference to empty object. So let's go next. So we already know what's limit when we can skip. Vice versa, just limit our stream by first 2, 3, 4, doesn't matter. But also there, if you need to take from the end of your stream, you can use one moment, called operator called skip, which do pretty much the same, but skipping the first 3. It's 1, 1, 2, 3, and then it's return the last 2. Yep, just 1 and 3. So here I had some examples. Maybe we could check if we are understanding and in the chat, for example, we have its stream. Let's be arranged from 10, and then let's skip like 5, and 3, and again skip 1. So can you write in the chat if you want what's the result will be here? Oh, sorry.
Do you need to skip 3 elements on the last line?
Let's skip 1.
Okay.
Won't be enough. So as I remember, range just creating element from 0, 1 until 10, including 9, but not 10. And so, one moment, where can I see?
Yeah, we don't have comments in the chat.
Okay, so let's just start explain how it works. So we created from 0 to 10, then we skip first 5, so we have 5 to 10. Then we limited 3, it will be 5, 6, 7 after that, and then we skipped first 5. So the answer will be 6 and 7. That's how it works. Now let's see how we can order our stream. Stream of like yeah, just so sorry. So we already had a parameter sorted. Okay. All we need just to sort our data from minimum to maximum. Yep, this one. And if we want to do vice versa, all we need to do is just add some function here called comparator. Anything. We just need to say it's reverse. Yep, it's reverse order. That's all we need to do, just make it vice versa from maximum to minimum. That's how easy to sort any amount of data. So another one, it's called distinct. So for example, here you see we have two values the same, and for example, we need a unique amount of data, like a set. Here we can use an operator called distinct, pretty much the same as in SQL languages. Yep, you can see we have only 1, 3. The second one was removed by distinct. And any, if I add 1, 1 or 2, of course, it will be removing by distinct.
Yeah, distinct can be very useful, but just to warn you about possible performance penalties, distinct operator has to remember all the data that it has already seen in your set. So, for example, if your set is like 10 million elements and you want to pick only distinct ones, You have to have a set of size 10 million that stores all the data. So sometimes you cannot avoid it and you have to take this penalty, but otherwise it can be just too expensive for you.
Yes, of course, when we have a big amount of data, it's always recommended to remove as much as possible by filtering or limiting or anything else. And then when you can't do it by some condition, only then use some operation like distinct or any math operation to improve performance. And now I wanted to say about another operator which is not used very often in the programming, but it's what's with my hand today? But it's used pretty often with sorry for debugging. It's called pick, and how it works. It's work pretty much the same as for each. For example, we can print out everything like system out like format first and but what's the difference between for each and pick about terminal operations? Terminal operations, they kind of consume the stream. For example, you had data, you created a stream, then you use terminal operation, even if it's just for each, and you just print it out, didn't do anything, and then you want to do any other operation with that after terminal operation, you won't be able to do that. Even compilator won't allow you to do that, because kind of terminal operation destroyed your stream, and now you have to create new one. And you can avoid it by using pick. Underneath, it's kind of also consumes the stream, but it's creating and returning new one with the same type. So after this one, you can do anything like, again, now distinct. Again, and do another operation like any, and then use for each to finish your. So now we have what we have. Yep, I printed out something weird. So it doesn't matter. We need to do more beautiful code. Just the idea that you can use pick as a middle, not terminal operator if you need, mostly for debug purposes to see what's happening with your data. So often you lose some data in the middle of your stream. Let's go next. Let's create a stream of 3, 4, 2. We have an operator called take while. What it does, it's returning the data until the condition is met. And here we need to pass the condition, for example, x less than 3. So you see, we took first, because 1 because it's less than 3, 2, and 3 we didn't do because it's more than 3. Even this 2 is less, but it's take until it's meet conditions. The rest won't be included to our string, to our result. And vice versa, we have operator called drop while. That's the same, but vice versa. It's dropping. Yep, we actually dropped 1 because it's below 3, then we dropped and removed 2 because it's less than 3, and from 3, 4, 2, 5, we returned. It could be a little, for example, vice versa, more than 3. So, just think what the answer would be, drop, and what the rest would be.
Let's probably give a minute for everyone to think. We have a question about this peak example. Why did it output first something, then second something, and then first again?
Where was it?
It was.
I guess it was
this one. Yeah.
First, second. I guess it was in the result. Or no?
Yeah, so it prints first 2, second 2, then 4. Then again first 3, second 3, and then 6.
Oh, let's write some more differently. Cheat and
Yeah, I think the question is why didn't it write first 2, first 3, first 0, first 1, first 3, and then all second messages? Here's the example. The answer would be because streams are lazy and they're trying to execute as few operations as possible. And for example, in the end of this stream, you could have operator, for example, called find any. It basically returns some one element from your stream, and the stream wouldn't need to process all other data except the first one, the first element. So it would write first 2, second 2, then 4, and just return 4. It would not filter or map your other elements. So it's basically the methods to increase the performance of streams. Okay, so I hope it answers the question. And we don't have answers to your task again.
Okay, thank you for the answer. So the answer here, let's check first and then explain. So we have 1, 2, 3, the full stream. Why? Because we check first element. If it's more than 3, it's not more than 3, so it false. That means after that we return all of it, because sometimes it's confusing. People think it would cut here and remove just 4, 2, 5, and so on. So let's go on. So it was most of the basic non-terminal operations. So now let's go to so the first one, most used, you already know, it's for each. But also we have some for each order. Let me create a string. Each from 1 to like then we use filter like it's divide 10,000 equals 0. Oh, oops. Wait, so it. Let's start from just for each and print out. So don't worry about it. I just created it to make it longer for further example. One moment, I'll show what it's look for. So it shows you from 1 to 10. Yep. And I don't know if you learned about parallel programming, creating like threads, multiple threads, and dividing it. But here in the streams, it's also very easy. When you have a big amount of data, want to create some parallel calculation, you just need to say it's parallel. Now it's going to perform much better most of the time. But in parallel, we cannot know which thread will be finished first. So if we want to print out the same, let's look what's going to happen. See, 796 2, because it's returned data as fast as it finished the calculation. And when we need to do parallel, but we want to keep the order, we can use for each order operator called or yeah, this one. And now, even though it's randomly, it's gonna wait all the data, then sort it and return as it should be.
Yeah, and again, it would require more CPU, more memory probably. So if you don't need some restrictions, like you don't need ordered data, don't put this ordered. So use it only when you need it.
Yeah, of course, because sorting it's the same algorithm of bubbles or anything. It's double loops inside. So now let's see some terminal calculation. For example, when we need to count something, let's create one moment. We already had some in stream. It's this one would be okay, I guess. One moment. Let's use this one. So right here we add count. Yep. Yep. Sorry, a little bit confused in my papers. So no. So let's create from start. So we have stream range from 0 to 10. And with x and length also range from 0. That's great. So it's a little bit more data. So for example, we have this pretty long string, and now we want to sum up all the numbers and calculate the sum of this. So all we need to do is just to write operator, and this one is going to return not string, but it's going to be integer or long. Out. Yep, total amount of sum of this one is 45. That's how easy to calculate this. Now, let's see how we can turn some integer strings into or just create any other like string half of and for example we need to create a we have a list of for example sure, and it's our list. So how we're going to do that? We need string and call. Actually, there's a couple of ways to do that. We can use just operator to list. It's going to create lists. I just didn't import it twice.
Yeah, but just to mention, this to list appeared not that long ago. I think it wasn't there in Java 11, so maybe it's here just from Java 13 or 15.
Yeah, and then another way is use collector. Oh, it's even idea is clever. It's showing me that I need to pass operator collector to list. And also it's pretty much the same if you have instead of list, for example, set or map, you can instead to list use to set or map. This one. It's how we're turning stream into something we need. And collectors, by the way, it's pretty powerful function. We are not going to dive into all this possibility what it can do. You can check it in the docs because there's really a lot of things to do. Let's show what it can do with so first we create a strings from it. Let's already we did it before, like other of so now streams of strings, and for example we want to concatenate it into one string instead of array or list. We can use string collector and on this one and use collectors and say joining. One moment. What's wrong? Collectors, it's different. Joining. Yep. So this one would return a string, a simple string, not an array. So we can use just string. We print it out. Yeah, we can see just it's one string contains all of it together. But also joining, we can apply some filters, for example, delimiter. All we need is indicated in like through dash. So now it's more beautiful. We can see just that it's different element 1, 2, 3. Or we also can apply prefix and postfix, just adding, for example, let's use curly. Like it's like this one. So now it's even more beautiful format of string. It's just string, and there's actually a lot of more different things you can do. Let's.
Yeah, I'm sorry, I think we are running out of time. We can actually skip the rest of collectors. You showed the most useful ones. Did you have any other operations to show?
Okay, I wanted to show some complicated operatives with collector to map, but let's skip it and show just another important thing. It's reduce. Let's fully use this one. What it does, it goes through the elements. For example, count and x. For example, we wanna sum them. This one. And it also return integer. So here. How it works. Account, it's this number 1, and x, it's this one. So we just take 1 plus 1 plus 2 plus 3, and at the end we have 7. Also in Java 8, as I remember, they added the new format. You can use this one without ACK. So in this case, instead this variable, we're going to use the first element, and then x will be second, third, and so on. But in this case, because we don't have a first element, the stream could be empty or null, so we have to use some like optional. So what else I wanted to say? Min max, it's pretty much the same as count. We had count. Yeah, like this one. All you need to show at the end. Say max and say integer and show compare. And it's going to return the maximum element, and the same with minimum. You just say min and it's return the minimum high count. About find any and find first, do we need to include this one, or we don't have time?
Yeah, I think it's easy to understand what they do. From their name, just find any may work differently in parallel streams. I think it's a bit too complicated. Let's probably go to the questions. We have some of them, and then we'll be wrapping up. Yeah, we have several comments that actually sometimes stream creation is called this third type of the operation, not just terminal and intermediate. Okay, you may include it, but I think not all sources do it. The question is, what is the difference between take while, drop while, and filter?
Take while. So take while, it's gonna start from the beginning and go through all element until conditions is met. So if, for example, if we have 3, then 2, or actually let's make condition like less than 10. In this case, it's going to return the whole amount of stream. But if we indicate like less than 2, we check first one meet, the second one doesn't meet because 2 not less than 2, it's equal. So we're going to drop all of this and return only the first one. Drop.
No, I think the question was exactly about take while, drop while, and filter. The filter will return all elements that match the condition, and so, for example, take while will only take elements until this condition is matched. And here, if we take while until x less than 3, then we will have only the first 2 elements, but we will not have the second and the third 2's from this source. So you just get rid of the part of your stream there.
Yeah, like for example, we're creating some lottery and watching some happy ticket, and we go take while the ticket equal happy. And when we draw this one, so we terminate the stream and we don't need anymore. So something like that. And filter we need when we need to go through all the stream and make sure that we covered all the data.
Yeah, I don't see any more questions regarding this topic here, but there was a discussion on fork join pools in our chat. Thanks, guys, for an interesting discussion. I think we will be wrapping up this light talk. I just wanted to remind you that we have a 100% free and online Java school from the very basics of Java up to some modern frameworks. You can go just mjc.school and enroll for free. Thank you, Alibek, for this great presentation, and thanks, guys, for joining us today. See you the next week on the next Light Talk. Thank you and bye.
Thank you, everyone. Bye.